Good afternoon, everyone, and welcome to the last panel of the day. This is a panel on U.S. government initiatives beyond 5G. Very excited to have to moderate this panel. I'm Abhimanyu Gosain, Senior Director at the Institute for Wireless Internet of Things at Northeastern and one of the co-organizers of the 6GSymposium. It's been a nice long day discussing all the technical nuances of 6G, all the different roadmap activities, as well as hearing some prepared remarks from industry and academics, as well as through some federal agencies. So we're going to continue that discussion. We're going to try to parse out and tease out what's happening in the US as it comes to developing a roadmap of activities from various different federal actors, federal research development centers, as well as some non-traditional defense contractors around beyond 5G and 6G. To kick things off, I'd like to hand it over first to Congressman Bill Foster, representing the 11th Congressional District of Illinois, for his remarks, and then we're going to kick off with the other panelists. Dr. Foster, the floor is yours.
Well, thank you. Thank you for the introduction. I'm Congressman Bill Foster. I sometimes introduce myself as saying I represent 100% of the strategic reserve of physicists in the United States Congress. But I guess I'm also 100% of the strategic reserve of integrated circuit designers. In my career in high energy physics, I actually designed 10 integrated circuits, every one of which worked perfectly the first time, something I'm very proud of, except for one time where I got rooked by an inadequately documented design rule. So it wasn't my fault. Just with that off of the table, I am also represent 50% of the strategic reserve of AI programmers in the US Congress. My partner in that is Representative Obernolte, who has he's the ranking member. I'm the chair. He's the ranking member of the Science Committee Subcommittee on Oversight and Investigations, which is a broad remit. And so he and I spent 2 hours this morning getting a classified briefing on the origins of COVID, and another hour getting a briefing on what the federal government can do looking at cyber vulnerabilities in open source software. So I want to reassure you that, no matter how bad it seems about Congress having no technical capability, there's at least on both sides of the aisle. There's a smattering of people that really are engaged in these issues. Another example that we were just chatting about a moment ago, in the Science Committee, we had a recent hearing on what we do about spectrum interference between satellites that are trying to measure the moisture content of the atmosphere to understand what's happening with global warming and get better weather forecasts, and how that may or may not interfere with the expansion of the 24 gigahertz nearby. And so that sort of highlighted a couple of things. First, since these systems are increasingly software defined, you have a lot of flexibility to do stuff. And so it is not out of the question to have essentially software defined quiet time as a satellite passes overhead, where you can simply say, the owners of the satellite have negotiated, stay away from this 24 gigahertz band for the next couple minutes while it measures the moisture content of your atmosphere nearby. That sort of thing with appropriate international cooperation are possible. And it's going to be an important part of that. And another thing that's going to be crucial is cybersecurity in all of this. If you look at the hyper-connected situation, just imagine the recently exposed exploit against iPhones, where you simply send a text message with a malicious, pointing to a malicious PDF file, and bang, you own the operating system in the cell phone. If that had been programmed to take over every cell phone that's been taken over immediately sent text messages to every other cell phone on its contact list, you would have, in the period of minutes, been able to take over every cell phone in the country, in the world potentially. And so when that happened, you then have the possibility of having a malicious actor broadcast coherent interference from every cell phone in North America. And you can imagine, really bad things happening. And it's not just cell phones. They're sort of the leading edge of this in a world where everything you touch has embedded processing in it. It's going to be really important to get your cybersecurity right. And the problems go all the way down to the silicon. Probably many of you have looked over. I would not like to be an AMD executive right now, trying to figure out how to deal with this exploit against their cloud-based chips, where you do something very clever. It's not obvious it would work to extract some keys that were never meant to be extracted, and then have an exploit against all of a big class of their cloud-based processors. And trying to understand, how we limit the exposure to that sort of thing is something that, I know Congress struggles with. We can hardly pass a law that says don't do stupid stuff. It's sort of like telling a programmer, I don't want one stupid line of code, because, you can do everything perfectly, and then one misconfiguration in a database and you've exposed all of your customer data to the world. And so trying to understand how we get around this from a regulatory point of view it's going to be the work of generations, probably. And we have to more and more insist on systems that are built from the ground up with cybersecurity in mind. And that's all the way down to the silicon. I wouldn't be surprised that we're going to have to end up throwing away a good fraction of the first pass silicon that we deploy in the advanced software-defined networks, because we're simply going to find that they're not up to snuff of what we're going to need when we're depending so much on this. And so, there's no shortage of nightmares that keep people awake in this business, and trying to figure out the right level of direction that Congress should give the whole enterprise. It's an ongoing struggle because we tend to fight the last war. You can see that in what's a good example? Oh, the coronavirus, where with the National Strategic Stockpile made a bunch of anthrax vaccines. Okay, that wasn't too useful when COVID hit, and so the same sort of problems can happen in software security. There is going to be a really important debate that will last forever about privacy, because when you have data collected by every piece of electronics, what used to be inanimate objects are now parasitically collecting data. We have to have understandings about when you have in a private circumstance and when you're not. And at the heart of the privacy thing, when you talk about what will you actually implement, you get to having a secure digital identity. That if you expect to be in a position when you can come up to a company and say, please tell me the data that you're keeping on me, the first step that you have to do is identify yourself as a legally traceable human being, and not someone who's just trying to steal your data by imitating you. And so for many applications, we're going to need a secure digital identity as really a fundamental right of every citizen. There's a lot of relevant work happening in Congress in that as we speak. We're in the process of spending many billions of dollars of your money to get pretty much a guarantee of a low-end broadband connection and a low-end cell phone in the hands of really every American who's competent to operate a cell phone. That this is going to become a de facto right of every American, and I think some countries have it pretty much already. And so that's when that happens. I think a crucial part of the training that anyone should get when they get access to a subsidized broadband connection is that you should understand how your digital citizenship should work. There are these very interesting products called mobile IDs, or digital driver's license sometimes, which essentially put the information on your state provided, but essentially government provided driver's license or other state provided ID. You put that onto your cell phone and then take advantage of the cell phones and the very advanced AI capabilities of modern cell phones, essentially to recognize their owner. And then what you have is a single legally traceable human being, a real ID compliant government issued ID, and the cell phone, which is a single legally traceable object, with a secure compute capability, a key storage capability, everything that they broke into with the AMD processor, but having that done, much, more solidly. That will be these three things: your piece of personal electronics and your government provided ID will be the root of authentication that will be necessary to defend your privacy. Because for most people, They understand these giant databases are out there, but they don't understand the rules. They kind of know that government can get at those databases under some circumstances, but they don't know the rules under which companies or cops or just random people may be able to access that information. They want clarity there. And for most people, their real worry is not so much the existence of these databases, but the thought of someone impersonating them online. And that stops when you have a secure digital ID. It's something that our office is working very hard at. And the first step in that is actually to get the government to raise its game. There's a big narrative that's happening right now it's been going on for 50 years at least, ever since the Great Society programs, about the level of fraud in federal benefit programs. That debate will stop when you have a secure digital ID that allows every citizen who qualifies for the benefit to get the benefit. You'll have some assurance that you won't have your IRS refund stolen by someone impersonating you. And just the efficiency gains in government and the assurance gains that the citizens will get about the level of fraud will go way down. And trying to make sure that happens without installing the surveillance state that the Chinese government is imposing on many of all of its citizens. That is what we have to come to agreement with among the free democracies of the world. And that is, I think, a big part of the work of our generation and the next generation to decide what the rules are for privacy, and in an age when data is being taken on you continuously, and we have to decide when you can keep it. Anyway, I'm happy to talk about anything from spectrum sharing to secure supply chains, another big issue which is very much at the forefront of Congress's mind, or anything else you want. And
absolutely. Well, thank you again for your remarks, Congressman Foster. So first off, I just want to let the fellow panelists react semi-real time to some of the remarks. I believe these are some of the more comprehensive remarks we've heard. You've touched on so many different topics that in itself could lead us down. And I believe all the stakeholders, some which are sitting on the federal agency side, have something to say about the investments they're making to tackle these challenges. And then others on the FFRDC and the non-traditional defense contractor side will have common pain points. But I'll open the floor up. Maybe I start with you, Andy.
Sure, right. And again, first, thank you for inviting me to participate in the panel. And Congressman, you said a lot of things that resonate, very dearly, right? I mean, whether it's looking at software and ensuring that that the software that's increasingly a part of all of the different ecosystems, 5G, let alone 6G and beyond, it made me immediately think of software bill of materials work that recently so Alan Friedman until recently at NTIA was working feverishly on pushing that ball uphill, and he's doing the same over at DHS now. So I think that is certainly key, right, in looking at our software security moving forward. Broadband infrastructure, right? You talked about, right, an underlying right and access to broadband, right? And certainly, amongst the things that we see being a key enabler for the U.S. to compete in the 6G space is doubling down in the 5G space and ensuring that that broadband infrastructure is there, because I don't think that we're going to succeed as a nation in the 6G race unless we've done a good job building out that broadband infrastructure, whether it's based on 5G or not. And then you talked about spectrum sharing, and I think you'll probably get everybody on this panel salivating at the idea of spectrum sharing, because I think we're all perfectly in tune with the fact that spectrum is finite, that going from 1G to the next, the appetite for spectrum has increased 10x or more every time, and that looking at 6G is not going to change the equation any. And so figuring out once and for all how to do what you were describing, right, with regard to whether it's weather satellites flying over, or a radar system, or radio astronomy, whatever it is, solving that problem once and for all is going to be a key enabler in the 6G space as well.
Thanks, Andy. Mark, I'll go to you next.
Oh, thank you. Yeah, Mark Kahn with Lockheed Martin, Congressman. Yeah, I appreciated your remarks also. And as Andy said, yeah, it resonates probably with all of us. And from Lockheed, certainly on the spectrum sharing component, that's been a considerable issue for us in terms of managing our radar systems, which are designed now to have some level of interoperability and sharing in certain parts of the spectrum now. And the shift may be away from technologies that are simply out there trying to sort of passively monitor and then sort of control, and from some centralized place control that, to something that's going to have to be more disaggregated, where each of the entities become aware of what the other entities are in the environment, what their needs are. And as you said, then it can be a more dynamic method. And for what we're doing in the military, that's always critical. We never know if we're going to have centralized control of anything. So our ability to monitor, understand, predict, and interpret our environment and react accordingly, for the common good is clearly a huge concern, and part of what we're developing for OUSD now is, part of the work that's going on there. And second, the second topic, of course, that we resonate with is the cyber topic. For us, the notion for work we're doing where we're trying to migrate and pull 5G technology into the military systems to have parity with our military, the types of capabilities that are well known and understood by the general civilian population, to bring that into the military absolutely requires the equivalent of what you described as the digital ID, right? That needs to reside in every military communication system so that there's no chance of impersonating that system or interrupting command and control. So the technologies that are evolving now that are allowing us to put infrastructure underneath the operating systems of this user equipment and the base stations and the cores, et cetera, I think are critical. And to be able to monitor and track and validate that such that you can instantly prevent the type of attack you described, right? Where if there's been a change in a system and it's taking on a behavior that is no longer an acceptable behavior, you can go in and reboot that memory from the root down and start that over again. And that's kind of the intent, I think, of some of the emerging approaches that I think are going to come for us in 6G also. So thanks.
Thanks, Mark. So we have an audience question, Congressman, and I'm just going to paraphrase it. Essentially, the essence of the question is around back in the early 2000s, a lot of the telecom-related research was performed at universities rather than industry. Being a physicist yourself, again, the physics community has been at the forefront of all academics sort of coming together to define the audacious goals and the main problems that need to be solved, and then the significant amount of investment and funding that's required to address those challenges. To draw an analog for telecoms research, are there any, from your perspective, do you feel there's a decline in the US telecom research, and is it a cause of concern, and what should be done about this, either from a workforce perspective, either from fundamental research funding perspective, if you'd like to react to that question?
Sure. Well, I mean, this is one of these situations sort of like AI. There's a lot of hand-wringing now that academics can't compete in AI with the Googles and AWSs of the world that maintain enormous AI engines. And so that either someone is going to have to find a way to buy them the time on those machines. Similarly, just the total amount of money and effort going in on the commercial side of telecom work is just completely swamps the academics. On the other hand, academics are an essential pipeline of talent. And so we have two major pipelines of talent in this country. The first are academics, the second are immigrants. And it's for the 12 years I've been in Congress, one of my frustrations is that we do not have I routinely have been submitting legislation that basically staples a green card to a PhD degree. And I think a master's in electrical engineering should be on that list as well. And that we simply, this is a blunder that we do. I think, part of it, I think is kind of understandable in the sense of after World War II, we very consciously adopted, because of the brain drain, where we were just siphoning all the best talent out of countries that couldn't afford it. And we very consciously set up policies to try to gently push them back to their home countries. And the situation's changed, and that is an insane posture for the United States. And I think it's it's just something we have to fix. And that's been true for, 10 years ago when I first voted for this, and it's going to be true until we get it done. And so you just have to, all of industry has to raise their voices on this. We just had a defeat. We're hoping to get at least a big part of the DREAM Act and some additional things done through this reconciliation package. And the most powerful person in Washington, the Senate parliamentarian, said no. and so we are, in fact, that's not happening, and we're going to have to approach something else. But that's a big thing. And when we push back foreign talent, particularly in technological areas, we lose twice. Because we lose that talent directly, and we make it a less promising career path for people that have always dreamed of coming to the United States to, start a world-changing company. And that dream flickers out for a few people every time we say no to someone. So we have to fix that.
Thank you. Thank you for addressing that question. So Thiaga, any sort of follow-ups or remarks or any points you'd want to make based on the Congressman's remarks?
I cannot help but agree with him anymore, right? I mean, he hit the points that we all are in some sense in sync with that. I want to outline, I think going back to your questioner who said that we are losing capacity in terms of what we used to do before. I think still that the United States is at the forefront of innovation. What is different is that we have much more robust competition from many other sources. It's not just us alone. We were the only kid on the block, and now we have many more people playing in the same field. And it is a scenario we're not used to, and it kind of feels a little threatening, for us to not be the only superpower in some sense in the technological space, right? And I think one of the things I'm really heartened to see Congress pay attention to is they have re-emphasized time and time again the role that foundational research in science and technology continues to play in affirming US leadership. So I think in every bill, on a bipartisan basis, there's support for agencies, R&D in agencies like NSF, where I come from, and NIST, and even in the DoD labs, right? That is something that I think we all should take a lot of pride in, that the United States is definitely placing its priorities straight in terms of focusing on foundational R&D. I think everybody would be happy, I'm sure, in your audience, if that money was much higher than where we are today. But like I said, that's up to Congress to decide. However, I think what we are definitely trying to do is to make good use of the money we are given. And I think one of the examples that I like to point out is the whole notion of how millimeter waves came out to become something that we use in 5G, right, to deployments all around the country that AT&T and Verizon have adopted. 2010, just 10 years ago, nobody in the telecom industry or anyone was saying that millimeter waves is something that we can even use at that time. And it fell upon, an academic in NYU, Ted Rappaport, who said, hey, NSF, I want to do this study, give me some money. And while NSF said, well, everybody is saying no, but we'll take a chance and give you some funds to try this out. They tried it out and showed that this had promise. And that was not the end of it, right? They showed that promise, and everybody was thinking, well, it won't work. It works one direction, doesn't work the other direction. Then there was another academic in University of California, Santa Barbara, who said, hey, why Upamanyu Madhav, who said, we can use a bidirectional architecture where you use uplink to be the traditional cellular network communication channels, and then we downlink, we can use millimeter waves. And they showed a proof of concept in 2014, and within 4 years, we started seeing the first deployments in Minnesota and others where AT&T and Verizon had deployed trial networks. We changed the world so fast, from foundational research to translation to commercial deployments, right? And I think that's one of the reason is industry and academia have started to work very closely in this country because they each recognize fully each other's strengths and where their opportunities are by working with others. And we are seeing that trend in 6G. I mean, what is happening with ETIS, right? And what is happening with all the other discussions here. And many of the partnerships that NSF has provided, for example, with their most recent program called Resilient and Intelligent Next G Networks, companies are eager to work with academics because they understand the foundational research gap. They are looking for the next big breakthrough. When they get that breakthrough, they are best positioned to accelerate its translation into a commercial practice. And I think the United States is fairly unique in making that happen at a really fast pace, right? And all we have to do is, in some sense, keep capitalizing on it and bring more resources to the academics to explore and realize some of those breakthroughs. And I think our industrial ecosystem is ready to take that and deploy it into practice. Now, I think I agree with what Mark and Andy said, that it takes many stakeholders to come together to work on this. And I think we clearly see that in the telecom space, right? Networking, software-defined networking has changed because of that cooperation between academia and industry. In the spectrum space, it's a little bit more complex. There's a long history of what I call as distrust, or I want to protect my turf, that has been going on. And it is again a question of building trust among all of them to say, maybe I don't have to assume ill intent of all other stakeholders, but maybe I'm willing to give them an opportunity to see if we can work collaboratively. And DARPA did this fantastically by showing in the Spectrum Collaboration Challenge that if the parties involved work collaboratively, then sum of efforts can be much greater than the individual components working on their own. And that's in some sense a principle that we are trying to affirm. We just announced earlier this week, the Spectrum Innovation Initiative, an award going to a consortium of 27 institutions led by the University of Notre Dame, which includes partnerships with many leading companies, as well as many of the passive spectrum users, including the many that rely on folks like NASA and also the NSF, which is reliant on radio astronomy using these passive frequencies. And the goal of such an award, we hope, is to bring these stakeholders together and say, perhaps if we learn how to work with each other and affirm each other's principles of operations, we don't have to be stuck with the traditional way of allocating and using spectrum. And I love the example that the congressman just said about what if a software-defined satellite flew over and silenced itself, everybody silenced themselves for a while. This is the concept called the National Radio Dynamic Zone that we are seeking to deploy as part of the Spectrum Innovation Initiative. And we would love to see such concepts be tested. And again, leveraging the strength of their ecosystem, be put into practice rapidly. We have an FCC that is willing to take risks and provide more forward-looking guidance, and they are seen as the leading regulatory agency in the world when it comes to innovating with new models. And we have seen the multi-tier CBRS spectrum sharing as a great example of how it's working right now. I think we are in a great shape. We have the right pieces in there. We just have to encourage everyone to keep at it, right? Keep building the trust, working together, and continue to deploy continue to do what everybody does best.
Thanks a lot, Tiaga.
I'm inspired by that, actually. That was I should just say, in regards to the NSF and science funding, starting about a year and a half, 2 years ago, that we had in the science committee competing Republican and Democratic proposals to double the science budget. And we have recently unified them into a single thing that's at least passed the House. God knows what the Senate will do. But there really is a bipartisan understanding that fundamental research is the clear lane of government and academia, and that we are making a mistake when we don't fund that. One of the things that we do have to do is provide academics access to the sometimes very expensive things like access to the latest chip technologies. Because a researcher at a university can't really afford to have a custom wafer run on a state-of-the-art fab. But these multi-project fabs, what was the organ? Oh, Moses. I don't know. Do any of you remember Moses? Something that NSF did. Are you still doing it? Or I had heard that it's faded away.
It is active. It's not used as widely.
Okay, but whatever the spawn of Moses is, we have to provide the government resources to make it worth businesses' while to provide state-of-the-art capabilities, like access to test, a little piece of a mask for a wafer, a test wafer of so that they can actually make small scale tests of imaginative technologies. You know, I mentioned all this microwave work that you mentioned must have involved custom ICs. And
Yeah.
I hope the government paid for access to that, because that obviously paid off many times over. There's another thing that we do wrestle with, though, which is, you know, with the internet, the information goes offshore immediately. And so you do this fundamental research, there is no guarantee that you will capture the economic benefits of it. And there's a lot of, you know, congressional angst over the fact that you talk to a lot of these startups, they say, oh, we have this great idea, we're going to prototype it in the US and manufacture in Asia. That is a discussion we have to have in more detail when we talk about supply chain integrity and so on. You know, I personally have no problem that I guess it's the Dutch that sort of have the state-of-the-art wafer stepping and exposure machines. That doesn't scare me so much. You know, I'm actually okay with Taiwan if they didn't have national security challenges. But I think that we're going to have to appropriately define what we mean by a secure supply chain. And I think, you know, I hope that, you know, the wall that we have to define is going to be around the free democracies of the world, the ones with trusted court systems. Because when you have a privacy conflict, when you have a national security conflict, you really need to trust those on the other side of the border if they're within your circle of trust. And that's you know, that's an important ongoing discussion.
Those are really important points, and we will, in the next hour that we have on this panel, try to delve into some of those. You've really given us a great platform to continue the conversation. I'm just trying to beat the buzzer, figuratively and literally speaking, on your behalf. So really, thank you for joining us on this panel. Thank you for your remarks, and we'll let you go.
One last thing for everyone, for you and everyone listening. If at any point after you've gotten your $2 billion in Silicon Valley, you want to come back and spend part of your life in public service, or even if you're just a really good engineer who really wants to apply, with maximum leverage, your ability to change the world, please get in contact with my office, and I'll tell you what's good, bad, and ugly about running for office or even serving in the federal bureaucracy. That's an underrated way to make the world a better place, because when telecoms come to the FCC and they find that there are really good, engineers who understand their business there, and the regulation is being done sensibly, everything works better. And there is no substitute for having really high quality people in the federal bureaucracy. And so some of the greatest good that can be done in science or in business can be done making our regulations smarter. Anyway,
that's
I do have to.
Thank you. Yeah, appreciate that like motivational remarks
okay.
for the students listening. Thank you so much, Congressman Foster. So thank you. So we'll keep the panel going again. It was a great platform, great introductory talk. I'm just going to switch gears a little bit, and I'll pass it over to Dr. Sumit Roy to give us a perspective from the DoD side on the federal side as to what's happening to address some of the topics that came that were actually mentioned in the congressman's remarks, and then we get a feel from what's happening on the OUSD R&E side as thrust lead for the Innovate Beyond 5G program. So Sumit, over to you.
Hi, thanks, Manu. Afternoon, evening, everyone. Okay, so now for the predictable, boring stuff after those inspiring comments from Congressman Foster. So for those, excuse me, who don't know my present role, I'm an IPA with DoD in the Office of the Undersecretary for Research and Engineering. And I lead a program which is called Innovate Beyond 5G. I will, next couple of slides, quickly contextualize it. So Manu, next slide. So the best way to succinctly think of our team, which is called 5G to XG, is to conceive of this as a small startup within the big DoD bureaucracy. And it has been tasked via funding from FY20, so now it's sort of in the second year of funding, to essentially do a few things. The most notable, I expect many of you would have heard, seen press releases or read about it, is really for the DoD to actually acquire current commercial grade 5G technology from the usual vendors and deploy it on base. Okay. However, the entire purpose of this deployment, which is relevant to this conversation, is that it is not for DoD to simply become a user of commercial 5G, but it is to use it, and this is the term that is very appropriately used as a prototype for testing DoD-inspired experimental ConOps, use cases, as well as enhance. And when we say enhance, it is to use the 5G as a starting point, what I call on my first slides, 5G as a substrate, and to really look at use cases which are not front and center to the current ROI of the mobile operators. So, by and large, for those of you who have looked at the famous triumvirate that 5G is supposed to provide, the mobile operators are fixated on really improving your, via your broadband access, the same experience that essentially 4G provides. Okay, same device, same smartphone, same services, just better experience, right? And so that's only one of the three other, the triumvirate. And really, what's on this slide, what's of importance to 5G and to many of the other industry segments is those other 2 points, which is, the applications enabled by low latency and very high ultra reliable communication links, as well as the ability to scale to a very large number of non-human or machine, machine type devices, many of which are shown here. So by and large, why XG or 5G matters to DoD is really to look at these new modes of the ubiquitous connectivity, not just human to human, as in the normal sort of operating use cases, but really human to machine and machine to machine. And there, as you can guess, that while you're still waiting for your self-driven Uber to pick you up, the DoD may have many more pressing use cases that may actually mature quicker than this very challenging, sort of commercial service. Okay, and obviously, you already heard from the congressman the huge concerns that with these new modes of new architectures for 5G or beyond 5G, the ever decreasing belief in architected systems to provide either privacy or security. One of the things I didn't get to mention, but I counted the number of times both the congressman and Tiaga used the word trust. And what I was going to ask is that in a world where trust deficit is exponentially increasing along with everything else, and by that I mean trust deficit in the government as an insurer of trust, or big private companies as an insurer of trust, how do you actually build trust? So it seems like we all want to build trust at exactly the time when we have the lowest amount of trust in every possible institution, both government as well as big industry. So that's I think of all the things that, the next two generations will be debating, I think that will be at the top. And perhaps the answer is what Mark and others alluded to, start with zero trust as a basis of network design. So anyway, more on that later. Next slide. So this is why 5G or beyond 5G is important to DoD. And how are we approaching this strategically? And I think that, for the audience, and this is really the reason that, I'm in my role and my program exists, is that this is a real challenge, first for DoD, in the sense that DoD has always been late to the game. It has, waited for commercial industry to define technology pathways, whether it's telecoms, whether it's software, whether it's microelectronics. DoD is a big consumer which does not influence the technology landscape. And the reason it doesn't do so, it stays on the sidelines. And then once all of it is set, it then looks to adapt it to DoD use cases. This is the first time that DoD is early to the party. It is eating while cooking. It is experimenting. So the fact that we are adopting and adapting 5G as an enterprise owner at these 5 + 7 more, a total of 12 bases, where we stretch 5G technology towards use cases that commercial vendors don't have an incentive to provide, that itself is a very significant first. So in parallel with the investments like with NSF, and Tiago mentioned rings and many other such collaborative mechanisms that the DoD is part of, this is a very significant first for DoD. Institutionally, this is a very significant challenge because the DoD is now doing things it has never done before, which includes, working with academics, working with industry, and, trying to influence standards based on the significant assets, this infrastructure that it has already, invested in and will continue to invest in. So by and large, the funding for 5G and the funding for 6G is propelling DoD to be much more, proactive, much more insurrectional, behaving much more like an angel investment, aka Silicon Valley. Okay? So I think this early adoption, even if it's driven by DoD ConOps, is a significant game changer. And I think the last, question on this bullet side is really, one of the big ticket, as DoD becomes an enterprise owner, will at some point, and I think this is a big unanswered question, will we become an owner operator of those networks, like owner operators in the private, sector who are adopting 5G or beyond 5G? So these are very, very, very significant issues for DoD, and I think this will lead to, cultural change, in alignment to all the other things that have been talked about. Next slide.
Thanks, Sumit. So if I just jump in here and maybe I think this would be, if you want to bring the slides up as we sort of move through the next part of the panel, I just wanted to give Mark an opportunity to sort of react to some of what you've said, setting the stage for the DoD side, and then how Lockheed is sort of adapting. And as you said, 5G is essentially another technology that you're managing in addition to the large portfolio. So we'd love to hear your thoughts. And then how is this move from the DoD and the federal government side sort of moved the needle for you, or adapted your business model, adapted your R&D investments and your roadmap of activities?
Yeah, sure. Happy to do that. And as you mentioned, I'm currently serving as the principal investigator for a program at Lockheed Martin called 5G.mil, and it was started early last year. And at that time, we had a new CEO that joined Lockheed Martin, and he came from commercial wireless industry, from American Tower. And he had a mindset of how to, he had sort of revolutionary thoughts about how to change that industry back in the early parts of the 2000s. And he's looking to do something similar, at Lockheed. So for him, he came in and stated that the intent was to really revolutionize the way that this type of technology, as you were saying, Sumit, is brought to the DoD. So he has committed a substantial investment in internal R&D, and it very much parallels what OUSD is doing. We are standing up our own pilot systems and networks and test beds across all of our facilities here in the US. Many of the facilities we're standing up, and we're working, as Tiago had said, there's an ecosystem of working with the commercial vendors in this. That's a difference for Lockheed Martin, right? To be very, very working strategically with the large providers in a commercial realm. And as you said to me, the DoD is driving this for use cases. We're very focused on tactical usage. As you said, the infrastructure that we support is fighters and ships and unmanned ground vehicles, et cetera, that all need to be equipped with this. So as the congressman was saying, this drives us in a direction where we actually need more of the capabilities that are being promised in 6G than we do in 5G right now, probably more so than the commercial world does, right? We're operating at all domains. We have to be in the space layer, in aircraft, at sea, et cetera. All the security and cyber issues and the ID issues we talked about are all to the 10th degree, with DoD. So the trick is, how do we do this in a way that we maximally leverage the commercial availability of talent, products, companies, capabilities, et cetera, yet drive in this new capability and incentivize the commercial world to join us, in that journey. When they're comparing whether or not they're going to deploy to 100 million handsets or 20,000 aircraft, they kind of start to work the numbers in their head. So that's always a challenge, that we have to incentivize this connectivity. But I think the places, as you mentioned, and we've all talked about here, security and ComSec and multi-level security, that brings all kinds of new challenges that'll have to be developed sooner than later. And resilience, another area that we're very adamant about is many in the DoD feel that the waveforms that are used in 5G over the air are not appropriate for usage in a military situation. They're easily discovered, easily targeted, resulting in loss of assets and perhaps even human life. So there's a strong propensity to move to much more sophisticated waveforms and ways in which we control those waveforms. Like the topics we talked about before, are we able to suppress co-channel interference? In our case, it's often intentional, trying to bring our networks down, but in congested commercial networks, it can be quite congested in heterogeneous networks. So our ability to remove that interference, ensure we're not interfering with others, not transmitting energy where we shouldn't, that pushes array processing and smart antenna technology well past where it is currently in 5G. So there's opportunities for that. And then the last point I'll make, and I'll let the others chime in, is that for us too, the interoperability of our networks with all the legacy systems that have been invested in by the DoD is critical. That's also a non-starter. If you don't have the gateways that allow you to interoperate with these legacy tactical and strategic systems, that will prevent you from getting penetration into that market. So we're looking, we understand this will be years to roll out, but the intent then is to have a mix of networks, heterogeneous networks, again, looking more like 6G than 5G, where everybody is sort of self-controlling, interacting with each other, using artificial intelligence to understand how do you move data intelligently through a heterogeneous network that is dynamically in motion. The base stations are not stationary. So it's those types of challenges and issues that we're standing up our test beds, working with our partners, and would love to, Sumit, when the time's right, connect with your systems. I'd love to connect with the university systems and prototypes and platforms and prove that some of these things can be done sooner than later. Thanks.
Thanks a lot, Mark. I'm going to pass it over to Andy Thiessen next. MITRE, but also wears a few different hats. And I also just want to point out one of the questions that came in, which and Andy's going to tackle. And then I want to give it to Thiaga to sort of build on this point of access as well as this interconnectivity, and how does research build on top, especially that given that we are in that early fundamental research, pre-competitive, collaborative stage of research, how can we actually benefit across these different stakeholders? But Andy, over to you first.
Yeah, thank you. And then, so one of the things I want to do is just kind of quickly walk back a little bit and hit the workforce question that the Congressman and Thiaga talked about, to maybe double down on that a little bit. When we're all, right, everybody that's in this panel right now, right, is working on trying to hire 5G talent. It happens to be a very shallow pool of people. And one of the problems is it's a shallow pool of people. So we really need to grow and deepen, right, the available workforce, both domestically and foreign born, like the Congressman said, and maintain that intellectual capital that we're building those people inside of our industry, right? And so that question about academia versus industry with R&D, I see academia and industry being very symbiotic. Right. And so Thiaga may not have said it out loud right after the Congressman spoke, but I'm a huge fan of the Industry Frontiers Act, right? I think throwing, lots of zeros after a non-zero number at the NSF is nothing short of a good move. The spectrum innovation work that NSF is doing gets at another big problem, is that while, we certainly need to be starting at K through 12 in the STEM part of building our workforce, growing, as an example, a spectrum engineer, right? So a former colleague of mine that I respect a great deal, Mike Cotton at the Institute for Telecommunication Sciences, always drilled into me that it takes 5 to 10 years after somebody graduates with a master's or a PhD before they're a real spectrum engineer and can work in propagation. And I believe that. And so the work that, the Thiaga and the NSF are doing, right, is working to try to grow and accelerate the maturation of the workforce that we have to go work these issues. And I think that's fundamental to our success in 6G. Because if we're struggling to find 5G talent now, it's not going to get any better with 6G, because we're already widening the diversity of skill sets that are necessary to compete in the 5G space. 6G is going to further widen the disciplines that are going to be coming into that ecosystem. And so really deep, wide pool of talent. So getting into some of the stuff that's going on, today and the question that Dean asked in the Q&A. So the Next G Alliance, right, is an industry-led and created organization out of ATIS, right, the regional partner for 3GPP, which is the main standards development organization for 5G. So the Next G Alliance exists. It's working on 6G, right? It's industry-led. To answer your question directly, Dean, Next G Alliance is working on getting government participation. Right now, it's primarily industry and academics, so stay tuned. So DoD doesn't have a door yet to open, but soon. And so I think, part of, what the Next G Alliance is working on doing is working together to develop a holistic vision to see how North America compete best in the 6G space. And so certainly, working to try to influence, policymakers in the administration, right, to move in the direction that industry and academia and the government see we need to go for the United States in 6G, has to have the government at the table, right, in those conversations. And so that's definitely coming, and I think we're all looking forward to that. I can't speak to whether or not DoD is going to join. I think Sumit can field that one, but again, I can't imagine the major players working in the 5G space not wanting to participate in the 6G discussion. One thing that I'll do in addition to the Next G Alliance that MITRE's working on is, we have something called Ingenuity, which is where, most of MITRE is facing the government, right, and directly supporting, right, our US government customers across a number of different technical spaces. We created Ingenuity to specifically be looking outward of government, right, and looking at industry and collaborating with academia and industry. And the first big piece in the 5G pot that they're going after with OpenGen is uncrewed air systems, right? And working on how do you enable a 5G ecosystem for UAS for non-line of sight drone flying, right? That really is going to push the needle forward and allow that to exist as a business inside the United States. And so there's a bunch of major industry partners that are participating in that. There's a bunch of government collaborators, and I know Dr. Roy is certainly amongst those that are working on providing input into OpenGen on what DoD expects to see right out of the 5G UAS space. And so doing those public-private partnerships, right, I think are again key to building out, right, the necessary component parts or the Legos of what ultimately are going to allow us to succeed in 5G. And I believe that if the United States is actually going to try to outcompete our peer adversaries in the 6G space, we have to be dominating in the 5G space to actually successfully do that. And I'll leave it there for now, Manu, and just let me know. If
that's a great segue. I think, Thiago, if you just wanted to react to what Mark had said about, access and interoperability, and then I think I really want to tee up the public-private partnership question. Obviously, given there's been a demonstrated experience that NSF has had back in 2018 with the PAWR program as a public-private partnership. How do you see that affecting the next generation? So yeah, if you'd like to react to that, that'd be great.
Sure, and I think in terms of interoperability, right, there are multiple aspects to this, right? I think the first thing that one wants to think about is, interoperability within the radio network. I think that there is that part, right? So, and then there's also interoperability across the different types of radio networks that one has to think about as you're thinking about 6G. And I think it's a classic problem for the DoD because they have different diverse networks that are sitting out there, and you always have to worry about legacy and compatibility and all that stuff. And I think every generation of network designers, when they start out fresh, have interoperability as one of their design goals. And it is a fundamentally hard problem because legacy systems are not designed to be interoperable to start with. And therefore, by the time they get to the nitty-gritty of how to make it work, given how hard it has been deferred to some extent to the next generation. And I've seen this play out from the 3G to the 4G and 5G. And now I know 6G, the first one of the big goals is interoperability. I said, this is great, right? Hopefully this won't be the another punting exercise. There's a reason to hope for why I think this particular upcoming generation would actually be more successful at interoperability than previous ones, and largely that's because of the architecture of 5G, right? And the whole notion of virtualization that in some sense is changing how we design and architect networks. And I think by going into a more of a virtualized model, and that's also increasingly software heavy, I think it's easier for us to design networks that are upgradable on the fly, more easily maintainable to some extent, where the only constant that you really can't touch is the front end, radio front end, to some extent is deployed on the field, and everything else is sitting a little bit in the back end, and you can play around with it and upgrade it on the fly. It's not fully there yet, but I think 5G is showing us that it can be done. And I would like to point to some of the recent work that Microsoft Research and some of the NSF-funded researchers at Yale have shown, where you can actually deploy an entire complete software-based network, where you only have that front end, RF front end that's sitting out there. That's the only invariant, so to speak, with a hardware unit. Everything else is software-driven, right? Now, if that kind of a world becomes feasible in 6G, right? Every network, in some sense, you can create waveforms that are customized, right? And if you want to change the function of the network, that can be defined with just a quick switch of a profile, right? And suddenly your network starts behaving differently, right? Assuming you have the appropriate front ends, the same device can radiate, in a certain type of waveform and then switch to fulfilling a different function to do something else. And I think, if the holy grail, of course, is to get that into a form factor that can fit in a smartphone, or into some of the small IoT-like devices, and then suddenly, you don't have to worry about interoperability anymore, because hey, you just define what you want, what waveform we want to emit, and what the other receivers want to do. You deploy the profile on demand, and you have interoperability, right? It's a very, what I call a dreamy picture that I'm painting. It is nowhere close to reality yet, but we have seen the promising offshoots that 5G has put in place, and what the networking industry, by adopting virtualization, the data center community, by adopting software, commodity hardware, running nice customized software, has shown. And I think it's a question of putting these pieces together and just going down the path further and further and further, right? And again, I cannot speak for the DoD's constraints. The DoD has lots of operational challenges that they have to meet, and of course, budget constraints means that you can't just upgrade every network whenever you want to. But in the practical, in the commercial, what I call consumer world, where devices have a much shorter lifespan of 3 to 5 years, everything gets recycled, right? At least 90% of devices gets recycled within like a 5-year time frame. I can foresee a much more interoperability coming much faster across the different types of networks that we use and adopt today. And hopefully, in some sense, that gives us enough commercial impetus to make it part and parcel of all future design processes, which in some sense will then carry over into the DoD worlds and other things. So, so that's my high-level take on interoperability. And I think a key part of this is open source. And I know that, again, I know many of you here are familiar with, what's happening in the O-RAN world, and the push towards standardizing interfaces, which is a very fantastic first step, right? It's a required piece almost before if you want to democratize the ecosystem a little bit away from the big few vendors, you are introducing competition, and by virtue of that, you are also creating more choices and also faster feature development to some extent. It's still in the nascent stages, but I think the real holy grail, the reason why data center networks have succeeded is because, we had, tools like Apache, we had tools like, the companies like Databricks that built tools on top of this open source software tool chains. And we had Linux sitting there that was available for the taking, right, to be customized and played with. And if we eventually, right, hopefully, with folks like the many agencies on both sides of the Atlantic and in Asia that are keen on investing in open source implementations of our commercially available equivalent 5G stacks, if we keep up that effort, right, we actually can deliver greater gains in performance and also force the notion of interoperability as something that everybody has to wrestle with, and it will organically happen. We don't have to kind of, push it on somebody by saying, oh, standards, you have to be interoperable. It will organically happen. There are no commercial standards for virtualization, or for data processing in big data settings, but they have become the de facto standards just by virtue of adoption. And I think a similar movement in some sense is needed. And to the extent possible, I see many of the US agencies, federal agencies, interested in advancing that narrative because it does help them as well in ensuring the supply chain security, right? So, and again, we started off with interoperability and went into other things, but I see all of these as linked together, right? Interoperability requires some level of transparency, and this transparency can be delivered in many ways, of which open source is one, but open source also delivers you additional benefits, such as visibility into the supply chain and better security through that visibility, right? So that's like a high level gist. So I'll pause here.
Yeah, no, that's a great point. And Tag, I'm going to come back to you around the different models of engagement, but I think I just want to keep this theme going, and it relates to a question that's also been asked, which is around participation in industry standard organizations like 3GPP. So one of the basic tenets is around interoperability. On the commercial side also, there's still in action legacy 3G, 2G, 4G systems that are that have constrained, maybe if you want to call it that, some of the development of 5G. But going forward, it still remains that the SDOs are pretty much a place where a lot of the other industry and non-traditional stakeholders are beginning to emerge. So the question is along the lines of participation by DoD and other arms of the DoD, as well as other, possibly the likes of Lockheed Martin. So if you want to maybe react, Dr. Roy, Sumit, I'll pass it over to you. And if you'd like me to bring your slides up again, I'd be happy to do that as well.
Maybe the slides later. But I think
okay, sure. If you want to react, that's fine.
Yeah. So let me take up the issue of DoD or sort of DoD aligned vendors involvement with SDOs. That relates to the question that Andy fielded about the NXT Alliance. So I think one of the things people need to understand that the current SDOs that you're talking about, 3GPP and say IEEE, or let's say 3GPP as an example, it's heavily dominated by the MNOs and their vendor chains. It is a standards development organization for and by the mobile carriers and their vendors. So this question is an interesting question, that if 5G, as Tyaga says, or beyond 5G, upends the business model, that network connectivity is not just for the human consumer. Okay? See, frankly, at the end of the day, say what you like, we carry our mobile phones because of coverage, and that we ultimately settle for best effort. All right? So seriously, we talk a lot about quality of service, etc., but none of us are really paying in data, in our data plans for quality of service. All right, so that's the fact. All right, so the hopeful future is that the more mission critical. So this is where all of the things that we talk about, more mission critical applications. Where DoD leads and DoD vendors lead, or the equivalent in private industry where you have a hospital, or a serious, manufacturing plant, where the plant owner is going to be paying for quality of service, because you have to turn something on, some nuclear reactor has to be turned off, some switch has to be, enabled, or as marked ships have to be told to go somewhere and do something, right? There is no ifs or buts. That's what the revenue model for the network is. So let's be very clear that we are at a cusp that where the technology is seriously upending the business model, right? Now, in that new world, and this is what I hinted on in my slide, that, like other private operators, does DoD become, and that's a very serious question, does the DoD become an enterprise? Not that it is providing you and me, global coverage, which has unfortunately been how it's been constrained, previously, that the DoD wants to become an MNO. All right, or Lockheed Martin or somebody else wants to become an MNO. No, it's simply, so anyway, so back to that point that, this needs to get reflected in SDOs. That as if there is going to be a shift away from the MNOs and their vendor chains to be the only producers and consumers of this technology, then it must reflect in similar reconstruction or new construction of the standards process. So if you ask me, I think it's a bit of a misplacement to say, oh, we need to go modify or just, influence 3GPP or IEEE. There's a layer below. I mean, you don't go with the intent of, you don't jump into the finals of Wimbledon. You go through the quarterfinals and the semifinal stages, right? And what are the quarterfinal and semifinal stages? I think the steps that the DoD is looking to influence, along with the help of, its like-minded partners, are those what I would call the national stage, where you can have pre-competitive collaborations on the kind of issues. I think one of the questioners asked that, where can we create hooks that support DoD and DoD vendor-like functions and are not inimical to what DoD may want to do later. Now, you don't do that just simply going to 3GPP. You do that by having bodies nationally, and some of the examples are whether it's MITRE's Ingenuity, whether it's the Next Year Alliance, whether it's a National Spectrum Consortium or the many, consortia that the DoD uses with a lot of its partners. And these partners are not just, the big DoD vendor players. Increasingly, they include non-traditionals, academics and smaller businesses. We need to provide in those fora the same protections to intellectual properties, the same thing that the IEEE. So we need to mimic what IEEE and 3GPP does to protect intellectual property, and yet, create a forum where with trusted US vendors, you can have that discussion. So I think that's where DoD has a role to play, and the DoD vendors have a role to play, and that will occur as we look at this model of, private enterprises and DoD becoming, innovators and ultimately consumers of network services.
Absolutely. Andy, I want to go back to you, since obviously with Next Year Alliance, that is kind of part of the mandate, as well as all the stakeholders you've been able to coalesce thinking about beyond 5G and 6G systems. If you want to react to that question.
Yeah, I certainly resonate with everything Dr. Roy said. Having looked at certainly the past of what 3GPP has done, relative to, relative to standards development, right? We have, some really good specific cases where the government has been successful in influencing an organization like 3GPP, right? DHS has successfully standardized wireless priority services throughout 3GPP. The First Responder Network Authority, right? Impacting LTE and successfully standardizing mission critical push to talk over LTE, standardizing a direct mode capability. So there are examples of where the government has successfully gone in themselves to do that. But for the most part, those successes are based on, typically either somebody paying a lot of money or expecting to get a lot of money based on those standards, or dual use, right? And I think the dual use, model for government is really interesting, right? So for the most part, right, the most valuable stuff that we've seen being standardized that governments actually had maybe some initial imperative to go do, and eventually get picked up by industry to go do something else. And so I'll pick on device to device, right? So release 12 and 3GPP was standardized, proximity services was standardized years ago, right? Under the premise that public safety would be a primary user for that. It took 2 releases before we actually saw a modification of that for vehicle to vehicle, right, which became CV to X, which is now working on becoming the pervasive technology for allowing vehicles to communicate. So something that was originally intended, right, so certainly public safety, felt some ownership of that, right, is now seeing, potential explosive use, right, for something that people hadn't even been really thinking about at the time. And so those types of situations, I think, are the right places, where government can go in and try to do something. But, like Sumit said, right, I mean, you got to build those relationships, right? You build a coalition to go in to impact an organization like 3GPP, because despite the size of DoD, it's a very small rudder, right, in a very big ship with 3GPP. And so who your friends are matters when you go to work on a problem like that. Now, just very quickly to the Next Year Alliance. So one thing the Next Year Alliance isn't is it's not developing standards. right? It expects to influence the development of standards by espousing a vision for what it thinks needs to be done, but it's not going to go, put its finger directly on the scale of the standards itself. Now, all of its member organizations, I expect to be directly participating in standards in one way, shape, or form, but by itself, no.
Got it. Mark, from your perspective, and again, not to say you're the new kid on the block, but again, with this notion of the 5G strategic shift from the US government, sort of CONUS and OCONUS operations on a standardized technology beyond military waveforms, et cetera, from a network architecture system level perspective, what's your strategy on, around the standards issue and participation, or that, yeah, if you want to comment
Sure.
on that.
Yeah, quite a bit. And we are involved, in ADIS and NextG and ORAN and ONF. And we have representation, and we're being very selective about where we can actually participate in the working groups and be hands-on and influence. But some of the earlier comments are correct that often DoD members are seen as, well, they're nice to have in the room, but sometimes we don't even get to vote on certain things. Depending upon which organization, we can have a say about certain things, but not always voting privileges in some of the key organizations. And I agree with Sumit, that if we fundamentally are driving these standards such that not only can we introduce the technology and the capabilities that we'd like to have in there, I do think there is the big, $100 billion question is, if we roll out something like this for the DoD, yeah, is the DoD operating it? Is it owned by the DoD, operated by contractors? Is there the equivalent of a mobile virtual network operator consortium? And I think those questions are, of course, not answered, but for the DoD, that has to be a global mobile virtual network operator. And it has to have a significant space presence, to boot. So it's just different. And I think the concept then of not precluding the players from engaging and developing the right kinds of organizations that could stand up that type of operations and not necessarily be a classical MNO. They can get all the parts and pieces they need from the ops components of it, et cetera, and not necessarily have a direct linkage, like I said, with the MNOs, because there'll be quite a bit of the infrastructure that simply cannot be owned by the MNOs and cannot be leased. It's not the usual towers and things like that. So there's got to be a hybrid model, and I completely agree that the standards bodies can set that up so that can happen. And that's certainly our intent. We would like to be a player in that. I think the DoD would like to have a role in that, but I think it's going to take a consortium of folks, from cloud service providers to MNOs to infrastructure type providers. This is not an easy thing to stand up, from scratch, as 5G is maturing itself. The MNOs are having a hard enough time, keeping up with it. So.
Right. So yeah, coming up to 15 minutes left, I want to sort of take maybe a little bit broader perspective. We've obviously, the panel is about US government initiatives. We've been a little bit insular, but just trying to think about what sort of a blueprint would, allies or, fundamental research supporting organizations like the National Science Foundation and the early sort of TRL 6162 kind of programs on the DoD side. What is it strategically that you think is going to have maximal impact? We heard earlier this morning from Congressman Lara around the committees in Congress sort of listening, and that was an important aspect, was listening for Congress to understand what are the pain points, what are the needs, what are the requirements. So Tiaga, if you could give us a little peek inside the blueprints or sort of playbook as you start thinking about NextG investments and the portfolio that the National Science Foundation is thinking through.
Right. So I like to say that there is two big things that are driving NextG. One is convergence, and convergence can be among many dimensions, which I can go over. But there's also something called the killer app, right? The demand for the killer app, and I know that this is a misused term. Because there's no such thing as a killer app. It doesn't kill anything other than our wallets. But the idea being that, is there something that's so compelling that we are all desperately dying to get that app on our hands, right? And one of the things that has distinguished 5G is the search for this killer app, where we have deployed a lot of this architectural changes and not much has happened in terms of what is the big breakthrough that is 5G going to enable. And the place where I see that happening, and again, this is the perspective from within NSF, and I know that this may or may not be something that everybody agrees on, is the notion of latency, right? Communications has always been about making things better and faster, right? And we have reached a point at 5G where, look, I am using a wireless network right now, and as if we are sitting next to each other in a room, and we are probably fine in the conversing part of the point. Where we don't have good trust over the network's performance is if I rely on the network to do something much more sensitive, right? Something that requires fine-grained control. Like, if I'm a surgeon who's trying to do remote surgery, right? Or I'm trying to, do something that requires a lot of short, what do you call it, less than, so I want latency guarantees, right? I need that kind of stuff to happen. That is not currently doable today, right? And we talk about augmented reality and virtual reality. And all of this means that you are basically driving your presence. You are pretending to be available somewhere else when you are not. And verbal conversation is just one manifestation of your presence, of your remote presence, right? Physical actuation is a much more harder problem to solve. And when we start looking at, so that's human level communication. And when we talk about machines starting to communicate with machines, they don't have the human bounds, right? You can imagine machines controlling machines all around the country, all over the world, or in the region, on much finer time scales. One can imagine, AI controlling fleets of trucks driving down the highway, right? Working with agents, autonomous agents that are on the trucks themselves, right? You need, yeah, exactly, and it's Skynet, right? So you are thinking about those kinds of compelling applications that have huge economic value that can be enabled if we can solve the ultra reliable, low latency communications challenge. And this is one of the features that the 5G has listed. And I think there are some early attempts being made, but the technologies are not there yet. So to me, that's a huge priority for the National Science Foundation. If we can crack that somehow, if we can provide delay guarantees and jitter bounds, we are changing, we are automatically going to be creating a new killer app for someone to find out. Okay. So the convergence piece of it is where I say, you have to look at convergence not across the wired, wireless boundaries, but also what I said before, across the different types of networks, right? I want to flag satellite networks as an important place where people have to think about convergence, right? It's not just networks, the terrestrial networks, it's also airborne and satellite networks. And when Starlink comes fully online and we start getting devices that can start talking directly to Starlink, right? And also you have a cellular interface, that's going to change the nature of the game, right? And so Next G in some sense is driving convergence to levels that we have not anticipated before. And this is where NSF's big investments are, like looking at convergence and looking at this kind of low latency communications. How do we enable these two things? So let me pause there.
Thanks, Yaga. So on the DoD side, maybe both, first for you, Sumit, DoD has sort of traditionally been seen as an extreme user of technology, right? So this is, and a lot of that then trickles down and benefits the wider consumer market, et cetera. So from your perspective, just building on this app question, the analog in terms of, tactical field operations, what are the main sort of key areas that you feel, your programs are going to be focused on as we sort of look at the fundamental research aspects that need to be solved for beyond 5G?
Well, Manu, thanks. So, I mean, historically, DoD has not been very successful in doing what you said, which is, despite its investments in technologies, it hasn't reached out and influenced, commercial, vendors adequately, appropriately. I think Andy was exactly right. There have been a few, one-off successes, but by and large, it hasn't, right? And as I said, hopefully, I think driven by this significant both sort of network architecture and the potential market disruptions that we mentioned, that looking at D2D, so if you think about this, I'm an academic, and I'm in the DoD, and the networks that I designed, just to pick up on Tiger's head, are fundamentally very different from a planned cellular network, right? A tactical network, by definition, is much less planned, much less expeditionary, okay? It operates in, contested, congested environments with famous statement by an ex-defense secretary, the known unknowns and the unknown unknowns. All right. So you're fundamentally defining, planning for resiliency, the kind of things that we put up in rings as, the first hour, right? So the basis of network design is quite different, right? And so if that becomes a significant characteristic of many networks, as Tiger is saying, based on heterogeneity, based on our, the sort of latency bounds that you now require, almost deterministic latency bounds, which is not feasible with our kind of best effort internet type of architectures, right? This signals a very fundamental change. And if in that fundamental change, the DoD is the lead, base, 6263 investor, no matter, because through these public-private, through these sort of collaborative relationships and through all the standard stuff, we certainly hope that it, bleeds over to dual use cases. And within that perspective, I will pass this on to Mark to comment. One of the things he didn't say is Lockheed, as his CEO has clearly, presented Lockheed's sort of physical platforms and assets as points of integration for other developers. So, so one of the key things is this, that you have, physical assets provided by, at scale large play, global, as you've heard, because, as Mark said, the DoD is a multinational. People forget that. That's where, our networks must operate globally. And you need providers who will provide that global scale securely, access, reliable, secure access. And to do that, Lockheed has to become a system integrator, meaning allowing other people, contractors, software and hardware components to play on their platforms, right? So the same thing that Tiger is talking in terms of open source, open standards-based implementation that academics and, the private sector relies on, the DoD has to, rely on very similar pathway planning, right? So,
yeah. So Mark, I'll let you react and I'll tack on a question that also came in around open source, around certification. And I think that's something that you've talked about and bleeds into the topics around trust, security. How do you provide a DoD functioning system if it is built on open source or open access kind of technology? So if I could just stack that on alongside what Sumit wanted.
And I'll make it quick. I know we're coming down to the last couple of minutes, but
that's okay.
Yeah, as Sumit said, one of the things that we are trying to build an initiative within the DoD and within the commercial and also with the universities. We're trying to build a coalition of the willing that would come with us. And I'll give you a very specific example. There's a split without getting too technical, a split in the 5G stack. The NFAPI split developed by the small cell forum or promoted by the small cell forum, 3GPP compliant. We would like to adopt that and expand it so that anybody that wants can bring a radio, as you were saying, that there's a radio that sits at the end of this thing. And if the rest is software, they bring their radio or their software image for their radio. That's their product, that's their intellectual property. They keep that, they maintain it. But we do adhere to a common interface where we address how do we interface at that split 6? How do we interface with the RIC controller? How do we interface? All of that has to be pushed by DoD if we're going to do that. And as I said, we're attempting to do this with commercial entities to join us in this, with universities to join us. We're trying to get 6 or 7 partners to agree to build waveforms and radios that will open up that interface. So that is, I appreciate you mentioning that because we recognize that cannot be a vendor-locked solution. And that's not a path to 6G, right? The path to 6G is all that's got to be open. So that's the one comment. And then as you were saying about the compliance, we recognize too that this issue with compliance and security, we kind of bundle together. And we're working with a strategic partner and we've stood up have an initial operating capability for a test bed that can exercise all elements of the 5G system, including threats on the core, at the base stations, at the user equipment, et cetera. And then we're again working with those commercial vendors to adapt those to address these new interfaces like we talked about, that if we're going to make modifications for DoD, how do we ensure compliance? Or if we're bringing in code like from ONF, that's open source, that's contributing, how do we verify? So every deal we have with every vendor now is we must have source code. Even if you're a commercial vendor with proprietary technology, it cannot come into our systems without going through a security scan. So that's a tough negotiating point, right? For everybody in this industry, but that's a necessity for DoD. You can't bring an application onto a platform, that has not been put through that rigor. So we're hoping that we do that ourselves internally. I know the DoD is looking to stand up sites, Joint Base San Antonio, other places where they'll be, building out that capability. So I think that'll come.
That's fantastic. And Andy, I'd be remiss if I didn't let you react to this notion, and then I think we'll have some closing remarks. But Andy, why don't you go ahead?
Yeah, just quickly, right? I mean, so the idea, right, of organizations opening themselves up to allow for other vendors, right, to come in and participate is, again, for me at least, one of those pillars for success for 6G, right? If we're really going to lower the barriers to entry for small and medium-sized companies to come in and compete at this space, right? The 5G ecosystem is already too big for a new garage shop to show up and start building infrastructure and compete with the likes of, Nokia and Ericsson. So creating a federated capability, where organizations are joining together and allowing for open collaboration on top of their own developed platforms, is pretty instrumental, right? And actually allowing US industry to step into this game, and for garage shops to go test their widget and collaborate with other people on whatever their particular niche product is. And, so like, the OpenGen UAS building a 100-mile air corridor, right, for organizations to come and bring their 5G UAS capable drones and fly it and see if it works, right? And we want people to, a majority of vendors to come and play in that space. So I applaud, what I heard from, Lockmart, right, to open up their doors to other vendors to come participate. That's outstanding.
Yeah, that's very interesting. And Thiago, last maybe comment from your side around this notion of federated testing, the common test beds, obviously with the PWR platforms, and there's been a lot of work there. Do you see a play for the test beds that the NSF has funded in here?
I think NSF started very early in the game, thinking ahead of what needs to happen, and we have learned a lot along the way, and we have 4 world-class test beds that are out there ready for running for big city-scale test beds. And we also realize that you cannot have everything solved by just a few test beds, right? Every test bed is kind of unique. There are some very niche test cases that you can enable only by having a little bit more control over it. But the idea is that by bringing the test beds together, and this is something that Sumit is doing in this advanced wireless test platform interagency working group, we are trying to kind of make sure that everybody's aware of what's out there. And by opening up access, it's again a key thing, right? We don't want to be reinventing the wheel and everybody investing their own $100 million into creating a new test bed design, right? We want to democratize access, make it open to everyone. So you gravitate to the ones that match your need for that particular experiment, and not one test bed will always meet everything. And that's the principle we like to embody with the Power program. It's open to everyone, right? Anyone can come and use it, including foreign entities. We want to have open democratic access. Now, I agree that others may have a little bit more restrictions, but we definitely want to see academia and industry coming together on these test beds, because and share the results. That's the other thing. You come here, do the test, don't take it and put it in a lock and key and nobody ever sees it.
Right.
Share the information with everyone, democratize data and the data that you get from it. That's something we would like to see as a future vision.
Yeah, I'm going to take that as the closing remark here, and also throw in the notion of the FCC having blessed the PWR platforms as FCC innovation zones, lowering the barrier of entry around testing, etc. But again, I really do want to appreciate everybody's time here, and thank you so much for sort of sharing the knowledge. sharing the roadmap of activities. It was extremely exciting to hear, and a lot of synergy on how different hats that all of you wear in your day jobs somehow is already converging. And I believe the dialogue should continue. And I believe all these different alliances, consortia that different partners are participating in is going to keep the conversation going. And we look forward to seeing you around for day 2. And that too also applies to all the attendees here. So that's the end of day 1. Hope you can join us tomorrow for day 2 of the 6G Symposium. Really appreciate your time and effort. Thanks, everybody. Have a great evening. Take care. Bye-bye.